Hello students, we will discuss one problem related to trigonometric Fourier series. Okay, this problem is very important. Maybe you will get this question in your exam. Okay, so problem statement is find the trigonometric Fourier series for the periodic signal x of t for the given figure. Okay, this is a continuous signal. This is a series of pulse, okay, or we can also call that one as pulse train signal. Okay, here t is the, we know that very well, t is the fundamental time period, right? It involves both positive cycle and negative cycle, positive half cycle and negative half cycle. The fundamental time period is, you have to find out. Sometime they will give directly in the problem, sometime by using in the figure, by seeing this, by observing this figure. So you have to determine the fundamental time period. Okay, you have to determine fundamental time period. Okay, so t is equal to 4 second. How we got this 4 second? So just you have to add these two, right? So you have to subtract, not add. You have to subtract these two elements, because how to do that? T2 minus T1, then we can determine the one cycle at fundamental time period t. Okay, so here the t2 value is 3, right? The t1 value is minus of minus 1. Okay, see here, this one is, so we have to take one positive half cycle, negative cycle, then it is we call that one as one full cycle. Okay, so we have to determine the fundamental time period for the one cycle. So the value lies between, that fundamental time period lies between minus 1 to 3. So we have, by using these two values, we have to find out the fundamental time period, capital T. Okay, so T is equal to T2 minus T1. So T2 is 3 minus of minus 1, right? So this one 3 and this one is minus 1, right? So T2 minus T1 is equal to 4, right? So the total fundamental time, the fundamental time period is 4. Then afterwards, this is the first step. Okay, so I have did this here. Okay, I have calculated here, right? So the time we are representing, the unit of time is second, right? The unit representation is very important. Okay, so now we have to calculate fundamental frequency, right? Omega naught is equal to 2 pi by t. Okay, 2 pi, we know that this equation very well. So just you have to substitute the value of t, right? We have already determined that value t here. Just you have to substitute this value here. Just you have to determine the fundamental frequency is pi by 2. So we know the Fourier series equation, right? It contains one DC component and the remaining two components are AC components, right? One is a cosine term and sine term, because generally the signal consists of both sine terms and cosine functions, sine function and cosine functions. So Fourier is a mathematician. He used that concept to represent the Fourier series, right? So a naught plus summation of n is equal to 1 to infinity, right? A subscript n cos n omega naught t plus b subscript n sin n omega naught t. Okay, so this is the mathematical representation of Fourier series. Okay, so by using this Fourier series, we are solving the problem. Okay, this is a trigonometric Fourier series problem. Okay, so just we have to find out a naught value, a n value and b n value. So before that we have to substitute the fundamental frequency equation, right? We know that that equation is omega naught is equal to 2 pi by t. Just substitute this omega naught equation in the Fourier series equation. Okay, after substituting that equation, the equation and also you have to substitute the fundamental time period. Here you have to substitute, first you have to substitute omega naught equation 2 pi by t. Thereafter you have to substitute the value of fundamental time period as if we have already determined this value, right? After this you have to simplify this equation, so then you will get this final equation. Thereafter you have to determine the DC component and coefficients of cosine and sine functions such as an and bn. Before that, we have to find out the function for the given signal, right? So x of t is equal to 1. So how I define this equation? Just you have to look into the given graphical representation, right? So this is the graphical representation of our problem, right? So here this is amplitude 1, right? So for the positive half cycle amplitude is 1, for the negative half cycle amplitude is minus 1, right? So here that 1 is lies between the time period minus 1 to 1, right? Minus 1 to 1, and similarly the negative value, the negative amplitude, negative half cycle time period is lies between 1 to 3. That one only I have represented as a functionally, right? This is the functional representation, right? So x of t is equal to 1. This is a positive half cycle mathematical representation, right? Functional representation. 1 for minus 1 to 1, and this is a negative half cycle of the square wave pulse, right? Or trine pulse. Okay, so minus 1 is the amplitude, with that one is lies between 1 to 3. Okay, now by using this functional representation, we are determining A naught, An and Bn. Okay, so first we have to consider the equation. We have already seen this equation, right? We have to consider that equation in order to find out the coefficient DC component. Okay, so A naught is equal to 1 by t integral of t naught to t naught plus t x of t into dt. Okay, we know that the t is the fundamental time period. We have determined this value. Just substitute that value, t value as a 4. Then integral, the integral lies between both positive. We have to take one cycle. Okay, this is a fundamental time period t. Okay, wow. So usually it is 0 to t, sometime t naught to t naught plus t. We have to take one cycle time period. Okay, here the one cycle lies between positive and negative. So that one, the time period is for this one cycle is minus 1 to 3. That one only I have mentioned here. Okay, then so x of t. So x of t is our given function, right? Our given graphical representation, right? So by using this, we have to write one equation, right? So 1 by 4, this is one time period, one cycle time period, minus 1 to 3, right? X of t to dt. Then again we have to split as a, this one is first positive half cycle, then negative half cycle. Okay, the positive half cycle, the the time period lies between minus 1 to 1. That one only I have mentioned as a integral. Okay, minus 1 to 1, and its amplitude is 1. So just substitute that amplitude 1 here instead of x of t into dt plus, again, so the integral, this is a negative half cycle, 1 to, right, 1 to 3, right, but the amplitude is negative minus 1 into dt. Just do integrational. Okay, integrate these two terms, then you know the integral of 1 is t, right? So minus 1 to 1 plus this one is also minus t, right? Integral of minus 1 is minus t, because we are integrating with respect to dt time, right? So that's why we are mentioning the t variable, which integrate between the values. Lower limit, the lower value is 1 and upper value is 3, right? So after substituting these two value, right, you know very well how to integrate, right? So the upper limit 1 minus of minus 1, lower limit. Similarly, the upper limit is 3. Here we have minus sign, so it becomes minus 3. Again, the lower limit is 1 minus 1, but here is we have minus t, so minus into minus plus 1, right? After simplifying this equation, we will get a naught value is 0. So remaining, we have to determine remaining two terms, right? And just now we have determined the value of a naught dc component. The remaining two terms are, two coefficients are an and bn. Okay, so first we will determine the bn components, bn coefficient. For that, we have to use the equation 2 by t. Okay, so 2 by t, integral of t naught to t naught plus t x of t into sine n omega naught t into dt, right? So thereafter we have to mention this fundamental time period 4, then the one cycle time period, that is minus 1 to 3, then x of t here is the magnitude, okay, magnitude of our trine pulse, plus 1 and minus 1. Then we have to multiply that magnitudes with the sine function. Okay, so before that we have to substitute the frequency value, right? We have to determine that value. So we know that how to determine that fundamental frequency, right? Omega naught is equal to 2 pi by t, right? So then if we have to substitute that t value for, then we will get that omega naught, right, frequency value as pi by 2. Okay, then you have to substitute that pi by 2 in this frequency, fundamental frequency. Okay, thereafter we will get this equation, right? For positive half cycle, the magnitude is 1, that one is multiplied with sine and omega naught. We have to substitute the value of omega naught as a pi by 2 into t, okay, into dt. Similarly, this is a negative half cycle of the trine pulse, right? So integral of 1 to 3, right, 1 to 3, magnitude minus 1 sine of n pi by 2 into t into dt, right? Afterward, just we have to integrate these two terms, okay, these two terms. Then we will get this equation, okay, this equation. After integrating, we will get this equation, okay. Then we have to substitute the lower limit and upper limit for the given equation, okay. I think you know very well how to do integrate, right? I don't want to teach again. So even though I will teach for the time being, okay, what is the integral of sine theta? Integral of sine theta is minus cos theta, okay. So minus cos theta into into so what, how we got this one? Minus cos theta divided by, for integral it will comes divided by, okay, n pi by 2. So just I have took that one here, okay. So it becomes 2 divided by n pi. Similarly, integral of sine theta means it is a, it is a, again it is a minus cos theta, right? So it becomes, here I have minus 1, that minus cos theta becomes, it becomes plus. So cos of n pi by 2 into t divided by n pi by 2. Here I have taken that, so it becomes 2 divided by n pi, right? Actually it should will come, it should have to come here, right? N pi by 2. So I took for simplicity, I have took this one as a here. So it becomes 2 divided by n pi, okay. So afterwards you have to substitute these limits. Then you will get again bn coefficient as 0. How we got that one? So just you have to substitute the upper limit and lower limit, okay. After substituting, we know that the cos 180 is 0, right? Cos 180 is 0, right? Otherwise, no need to substitute that one also. See here, cos n pi by 2, here also minus cos n pi. So it becomes 0. Again, here this is a cos 3 n pi by 2, here the cos n pi by 2, right? So for cos 3 pi by 2, it is a 0, right? Again, cos pi by 2, cos 90 is 0, right? So for cos 90 is 0, cos 3 pi by 2 is 0. So this term is also becomes 0. This 0 is multiplied with this